Good morning, everyone. Welcome to join this webinar of ZWCAD and Altyapı. I'm Rose, coming from the Overseas Division, responsible for the ZWCAD Global Eco Partner Network. It is my pleasure to be your host today. I can see many our users from Europe and many our partners, European partners, join this webinar. I saw all of you, so welcome and nice to meet you. Well, for the webinar agenda, first of all, you will be shared the latest news of ZWCAD highlight information. In the same time, we are happy to invite our eco partner, Altyapı, who worked with us for global CAD user surveyors over 10 years in the global market. In order to promote ZWCAD 2024 and aim to enhance the cooperation with Altyapı in widely regions, we decided to arrange this joint webinar. During this speech, Altyapı will present its ecosystem on ZWCAD 2024 with emphasis on the new point cloud future. Together with Altyapı, we will discover the powerful combination of application and 2D platform that improve the workflow in civil and surveying projects. Now, please allow me to introduce the speakers today. From ZWCAD, we have Mr. Enrique, the country manager of Spain. He will present ZWCAD company information. And Mr. Michael, our overseas technician, who will answer all of your concerns and your questions about our platform. And from Altyapı, we're happy to invite Mr. Antonio, who will be the main speakers to present the whole ecosystem of Altyapı. Okay, now let's begin our agenda. Enrique, please.
Hello, good morning, everyone. This is Enrique Xu, the channel manager from Spain. It's my honor to present the part of ZWCAD to introduce our company, who is the largest, the CAD and CAM software provider in China, which is all-in-one software solutions. So as you see, as the first and largest CAD/CAM company listed in Shanghai Stock Exchange in China, right now we have total employees over 1,800 employees, and we are cooperating with our global partners, over 260 partners from 90 countries or regions. Respect to the product, for example, ZWCAD has over 15 languages versions to supply globally to more than 1,400,000 users from globally. And as you see, ZWCAD was founded in 1998. And until now, it's just 25. It's now fulfill the 25 years anniversary just this year. And in 2002, we launched our 2D CAD solution, ZWCAD. And in 2004, we went to sell globally. And in 2010, we launched our 3D CAD and CAM solution. And then in 2019, we started a project which is named Wukong. It's a BIM solution. Right now, we are under the progress of the investigation and R&D to launch the in a near future. And in the year 2021, our company was listed in Shanghai Stock Exchange as a public company now. And in recent years, our company was rapidly spread in over the world. And regarding the R&D investment, every year we invest over 30% of our yearly revenues, and our R&D engineer teams grow very rapidly, over 40%. And till now, almost the half of our employees are the R&D engineer, which is located in six R&D centers in Guangzhou, headquartered in Guangzhou, and other cities like Wuhan, Shanghai, Beijing, Xi'an in China, and Florida of USA. And another point I would like to clarify is that ZW, including ZWCAD, ZW3D, that we are owning our own cut aging CAX core technology. For example, the 3D geometric modeling kernel Overdrive for ZW3D and the Eagle kernel for ZWCAD. So as you see, we are cooperating with our global partners in 90 countries. I believe that no matter which markets you are located, I believe our local partners will serve you well locally with the local service. As you see, we are aiming to construct a CAS ecosystem to satisfy not only end users, customers, but also to cooperate with our business partners, channel partners, and also third-party developers like Altyapı together to satisfy the end users with the whole package as an ecosystem. So as you see, in different subsectors or industries, we are cooperating with different third-party application developers. For example, Altyapı from the GIS surveyor and other applications from interior design, general tools, sheet metal, etc. So here, as you can see, that our solution, especially ZWCAD, is as a universal general purpose. The CAD platform can be supplied to diverse subsectors, industries, for example, agriculture, engineering, like civil engineering, construction, oil and gas, governmental, consumer products, etc. So in this part, I would like to introduce about the vision and the mission of ZWSoft. So we are aiming to provide the reliable all-in-one CX solutions to worldwide users, and as one of our mission to provide the reliable software to the worldwide users in the engineering world like CAD, CAE, CM, etc. to establish a sustainable and the all-in-one ecosystem for the design software industries. So here is the photo, is the blueprint of the future building, headquarter building in Guangzhou, which will be finished very soon. So we are promising to promote the industry innovation and the progress for the engineering world. So besides ZWCAD, we have the solutions like ZW3D, which is a 3D CAD and CAM software, and the CAE solution. For example, the ZWSIM, for structural simulation, ZWC electromagnetic, ZW Meshworks, etc. as the CAE solutions. 3 product lines as a combo, as a all-in-one, the CAX solutions for the engine all over the world engineering from different diverse subsectors. So nextly, please allow me to introduce Mr. Antonio Barto from Altyapı to introduce you the part of the Altyapı and how will we work the MTT with ZWCAD to satisfy the civil engineering works. So Mr. Antonio Barto, it's my pleasure to have you here.
Hello, Mr. Michael. Thank you for introducing myself. Okay, I'm going to share my screen. Okay.
Yes, please.
To speak about. The first of all, I'm going to introduce myself. I am Antonio Pardo, survey engineer from Altyapı, from the support team Altyapı, and I'm speaking about the workflow that the survey we need to follow in our question tags. For example, under the Altyapı ecosystem. In this graphical, we can see a circle where we can find a reality, a natural terrain that we need to measure. Okay, we can use our GNSS devices that we can control with the TCP GPS, or maybe we can use the data from the laser scanner, LiDAR sensor, or photogrammetry, something like that, that we can control with the TCP point cloud editor. And both of them are developed by Altyapı. Okay, with this information, we can process and import ZWCAD 2024 by TCPMDT. TCPMDT allows us to process the information, the data, and create a mapping or cartography, something like that, to analyze them, to design some solution in some problem in the reality, to create the civil survey, the civil survey engineer, okay, civil project engineer, and so that when we finish, we can take out this project to modify the terrain. In this example, we are going to make a survey of this street. Okay, we are going to take all the data, and the first of all is to running the TCP GPS to take the point in the field. We are going to connect our device, our smartphone, by Bluetooth with the GNSS, okay, by Bluetooth, and we are going to choose the working mode. In this case, we are going to choose the rover station by NETRIP protocol. Okay, I'm going to use the data, the connection of the internet by internet from our smartphone, or maybe by our SIM card or something like that. We can use we need to create a project where we need to type the name of the project, okay? And very important thing is to choose a right global system coordinate to organize the system reference. At the end, we are going to make a survey of this strip, okay? We go to start the application. In this example, is a question task that we are going to take point by point. It's entity of the field that represent the relief, like a brick line, like a curbstone line, different wall side, different line in the strip, or singular point like wheels or lamppost, trees, etc. To help us, TCP GPS allow us to use a code database where we can find a lot of codes that you use in the work, okay? So not only that, we can type a new code in the real time. If we need, for example, the vertical signal or something like that, we can make up the different code. We can use, we also use a code prefix that allow us to follow several lines, the similar characteristic by number, or maybe we can use a multi-code in only one code, in only one point. Okay, at the end, the objective is to take all points in undescribed by graphically all the natural terrain. We have several graphical screen. For example, we have this where the numerical screen where we can find the code database, or we can find the different options, or we can the graphical screen where we can see and verify which point we are take. Okay, during we are missing. Another important thing is TCP GPS allow us the layer manager, where we can control the different visualization of the layer. For example, we can visualize the point in different size, with different size, different color, or something like that. We can use a different remap, the community, for a street view, street map, survey map, or ortho image, or the background, another ortho image. We can control the color of the point, the shape, the size of the text. We can hide, or we can visualize different layer, or we can import by layer different format like DGF, or maybe GMES, or zip file, something like that. Okay. At the end, we are going to create to export the information that we took in the field, and we are going to save in one folder in our smartphone, or maybe we can share in the real time that information by mail, by drive, or something like that. In this case, we are going to share one list of the point with a structure, fixed structure, and we are going to drive to save in the drive, or maybe if we want by mail or something like that. Another thing, we can export several formats like MDT, GML, or ZWCAD, is the case in this question, where we can manage, we can control the scale or the text size. Okay, we export the information and we are going to treat to process in ZWCAD by MDT. ZWCAD 2024. Okay, open ZWCAD 2024, and we are going to open in the first step the ZWCAD. Okay, when we open this ZWCAD file, we can see that there are the brick line that we took in the field directly. Only brick line, text or points points from the CAD like this. Okay, and you can work perfectly because our entity organized by layer, something like that. But you can, if you don't use MDT, you can work with this information. Okay, but right now we are going to import the list of the point to repeat the operation to check the difference. Okay, so I'm unzip the file that I create with TCP GPS. I'm going to import the point. MDT has down a vertical menu, or maybe a ribbon menu, where we can find easy all the commands. And right now we are going to import the list of the point, choose the right structure. Okay, I think the most important thing is the representation of the point and draw from codes. Choose the code database, similar as the TCP GPS, to translate the code and the way of the representation, and draw automatically all entity in the draw in some seconds. When we import, MDT create a legend to allow us to interpret the map, okay, and show all the brick line that we took in the field, or maybe the punctual entity that we took, for example, lamp strip or wheel or something like that. Any entity are drawing in the map. We have a control visualization to manage the control of the point, to hide the different attributes of the point, or we can hide the different entity like a surface, like a contour, profile, something like that. Draw each point in right coordinate, in right scale and right orientation. If we took several points, we can change the scale of the point, or we can change the color of the attribute, or maybe we can change the location of each attribute according with the level of this point or something like that. It's many tools allow us to work in MDT. MDT offers us also to many commands to editing of the brick line. For example, in this case, we are going to make up the top of the curve, because we took in the field the bottom of the curve, and we are going to make a 3D parallel of this line. Okay, there is several points, several tools to make a different surveys. Right now we are going to make a surface to triangulate all the points according with the brick line. And here is the result of our surface. Right now we are going to draw the contour line. I'm going to make a distance. I'm going to use a palette of color at a glance, see the lowest or highest area. Okay, we can use several instructions. For example, like a quick profile, where we can find or we can measure some detail. For example, we can make a dimension for the car park in this case. Okay, here is exaggerate 5 times the cross file. Okay, we can use several tools like a water drop. Okay, where we can find the minimal path to solve when it's raining, for example, to locate the path of the raining. Okay, at the end we need to use all these tools to create a cartography, a mapping like this. Okay, that we are going to analyze, to work, to design, or something like that. In this case, we are going to import one horizontal alignment. MDT offers us a lot of command to create a horizontal or vertical alignment, okay, to analyze our surfaces or combine information, okay. And here is, we are going to make a cross section to cut the surface that beyond the take, okay. We are going to make a cross section of this. Okay, choose the interval, choose the width brand, and we are going to make choose the sheet in A3, for example. This is a sample of the cross section, and here is one example of the station 40, the distance, the natural terrain, etc. So we can mix all the information with, for example, a laser scanner, okay, because ZWCAD allows us import point cloud, okay? But we are going to attach this point cloud, okay? If we can check how fix our survey work in the point cloud, okay? This point cloud we can visualize with ZWCAD. It's very good option that offer us. MDT allow us to work with this information. For example, we can create a surface from this information using one category of this data. For example, we are going to use the ground category. We are going to triangulate only the point that that is a ground category. Okay, select the area of the work, okay, and triangulate all of this point. We can see or compare both surfaces, the surface from the survey work and the LiDAR scanner, okay. Here is the result. I'm going to draw the contour line in different layers, okay, with the same equidistance. And here is. I'm going to hide the point cloud. Here is, okay. Change the color of the layer of the point cloud to check the difference. And here is. There is some difference. It's not enough, but the difference is due to the precision of the accuracy of our data. No, there are some difference in the surveys and the laser scanner, also the LiDAR sensor. And right now we are going to create a cross section for both surfaces at the same time. I'm going to cut the same vision. I'm going to open with the cross section editor. And here is, we can check how we can expand our survey in the border out to complete our work in those areas where we don't have information for preliminary project or something like that. Okay, are very similar, and there are some difference due to the density of the point. Okay, and right now we are going to use the web map services to import one ortho image. Okay, select the right system, global system coordinate, and specify the Windows area. Okay, specify the Windows area. Later, I'm going to choose the resolution of the image in the server that offer us in the web. Download the map. Here it is. Okay. Right now, to explain that, we can merge both surfaces in only one. We can choose the survey work. We are going to include the lidar scanner to make a big surface with both surfaces. Okay, here is, we are going to make a color for this surface with the orthomage, and we are going to mapping that's all the triangular with this image. And right now we are going to make a virtual tour of the final surfaces with the virtual reality. Okay, and here is the result. This all surfaces, one surfaces with both surfaces. And here is. If we make a close profile, we can check the difference. Only one surface with all the information. And here is, we have the river on the left, the street from our survey work, and the lagoon from the LiDAR sensor. Okay, the point cloud information. Okay, and it's very wide. So in this tag, in this step, we are going to attach more information from the point cloud. We're going to attach a high density point from the manual laser scanner by SLAM technology. And here is a new point cloud, more accurate, with a very big density. I think is 40 million of points in only this area relative to the street. Okay, we can see the difference, and we can check that there are some far away, the point of the survey work is not adjusted exactly with the curve. For example, we need to edit that brick line where we can use ZWCAD to make this, but the tree or some information not allow very good, allow to see very good the brick line, because there are some noise, a lot of noise, something like that. For this reason, we are going to use or to introduce our application TCP point cloud editor. And this right now we are going to import both point cloud. We are going to see the difference of work with this application exclusively for point cloud. For example, we can see both point cloud by color, each point cloud by color, or the elevation map, or the real color for each point cloud, the map of density, or by category, que is a very good thing for each point cloud, because we can classify the information by category. Okay, as we can see the point if you use EDL, because it's a representation of the point where you use like a shadow around the point. Is very useful or very wonderful to see the point easy, and we can see the difference between ZWCAD. Is very, very good, but we have a lot of tools to manage that point cloud. Right now, we are going to make a simple exercise to classify to make a different category in this point cloud. For example, we're going to make a manual selection to change the category. Make a selection, choose the right category, building, okay, and then we accept the category. If I show by property by category, we can see the difference and before. Okay, we can repeat the operation. For example, right now in this tower, we are going to make a selection for this tower, but there are a lot of information. So we're going to isolate the tower. So we are going to make a filter in this tower to make a good selection. Okay, filter, and the tower here is alone. Here is make the similar or maybe a manual selection by polyline, select the right point that we want, and make a selection. Okay, change the category, choose the category, the tower, the transmission tower, accept the transmission tower category. Here is, it's changed. Restore the point cloud, and here is world the point cloud. Okay, at the end, we need to find one point of view to make a manual selection by polygon, like this. The cable, we make the selection and change the category. Okay, if we hide the different category, we can clean the graphical screen to make a different, to continue make the different selection. So this is way a bit manual, but we can TCP point cloud editor offer us a process automatically. Like for example, if we use a model, for example, we are going to use the model that you create in MDT and ZWCAD, and we are going to convert and grid information. Okay, we are going to visualize better. Here is, and with this model, we are going to make a selection for all the points that are minimum 50 centimeters from this model. For example, we choose the geometric selection by model, make 50 centimeters from the grid, and make the selection, apply, and here is. Is a right selection of the point that those of this point we could set that they are a ground category. Change the category, and here is. If I show by category, here is all the point classified by category. It's very useful for working. Okay. MDT offers us, TCP point cloud editor offers us a lot of tools. We can make a cross-section, for example. Okay, we are going to make a cross-section quick profile like before in MDT, but only remain that that this profile are points. Okay, so depend of the density of the point of each point cloud. For example, right now, if we select the bandwidth, we can see different point or not. For example, if we have a very high density, a very low density, we need to make bigger bandwidth to see the points that with different density. Okay, we are going to activate the dense positive highest. Okay, and we can check the difference. Okay, here is 2 meters of the bandwidth, and it's very high to the very high density. Okay, with this information is very useful to detect some line that we can see in the plan view. Okay, due to that category, we can select the right category if we want. We select only the ground point, and here is. It's very useful to analyze the point cloud. And in the same guideline, we can make a cut to the different point cloud. We are going to make a cross section with this horizontal alignment, for the same horizontal alignment. Okay, we are going to make a cross section, both point clouds, okay, with the same width band, and here is. Open, we can move station by station and check all entities, for example, the cable of the electrical facilities, the tree, the street, etc. And right now we are going to import the cross section that we create in MDT before. And here is, we can combine all the information to analyze and compare with each other. Okay, and here is, if we make a zoom in this detail, we can see the difference. For example, the point cloud has very precise. This is the wall, this is slope, this is the well side. There are the different due to the precision of the survey work from all the points we took with the point cloud, the laser scanner. Okay, the median, the different line, the car park, the sidewalk, and the fence in the right side. And here is, we can import the CAD from the ZWCAD that we have. Okay, we can visualize the different brick line and compare in plant with the point cloud. Here is, if we make import of the CAD drawing, select the layer that we want and make a zooming in the area that we want to focus. Here is the grid, here is the point cloud, and here is the brick line to analyze. Okay, we are going to show more layers, for example, the wheels, the asphalt, etc. And here is all the information. As I said before, there are some difference between the vertices of the polyline that we took in the survey work, and we need to make several vertices plus to adapt to the point cloud. Is better than the survey work because we take point so far. Okay, we need to edit some brick line to adapt to the point cloud. Okay, this is the curve, and we could adding point by point, or bien we can use we can draw directly a 3D polyline, or maybe some point to choose some point, etc. Okay, if we make a change the category, we can hide all category and select only the point that we want to show. This point, the ground point that we change, we are going to export to ZWCAD by format RCS. Okay, and this new point cloud we are going to import in ZWCAD to make easy our work in this CAD platform. And here is, right now, this is the problem to see all the information with the 3ADC. Right now, we are going to attach the new point cloud only with the ground point. Okay, yeah, we are going to hide the rest of the point cloud, for example, hide, and here is. Okay, right now we can see very good all the brick line that we took in the field. If we can edit, because we can use the point cloud easier if there isn't obstacle like a trees or obstacle like a noise or something like that. Okay, we can edit point by point, or we can draw directly a 3D polyline, etc. And edit our surface, our brick line to create a new surface, to create a new map, etc. At the end, when we finish our map, we need to design our civil project engineer to solve one problem. In this case, we are going to create a pipe to cross under the strip, one pipe to drainage the river on the left in the lagoon. For example, here is one project to design by MDT, and we are going to analyze, for example, the facility or the existing pipe under the street. For example, there is a clearance there nearly 1 meter, so there isn't any problem to create this solution. Okay, we can analyze this part with regarding the strip. For example, create the cross section of our pipe with the strip, and we can make calculate the different volume report, to very useful to create, to analyze in our reports. Okay, and here is the different layer of the trench. Okay, And we can print in several formats, Excel or something like that, to include in different books of our quantity to take off to analyze all the project. Okay, and then when we finish our civil project engineer design, we need to export that information TCP GPS to stake out this road in the field. No, for in this case, we are going to import our design. In this case, a road T1000. Okay, we can analyze or we can review the horizontal alignment or the vertical alignment to check the information. And I think the more important thing is to check the cross section that we are going to stake out. For example, here is the cross section that we can move station by station. Okay, check the subgrade section. Okay, check the each cross section station by station. Okay, with the natural terrain, the trench that we are going to stake out in the field, and we can show the graphical visualization of the numerical data like this. We are going to use some code, for example, the 80 code or the 139 code to see the bottom of the trench or maybe the contact with the natural terrain. Here it is. Right now, we are going to stake out that road. Choose the stake out. And here it is. When we are in stake out, we select the station that we are going to stake out, and we are going to choose again the cross section and the offset by subgrade selection, the right side. Okay, if we can select graphically the code, for example, in this case, we are going to use the bottom of the trench. Okay, right now TCP GPS lead us to the point, to the right position of the point that we need to stake out to make a mark in the field. For example, we need to move to the station 20. Okay, 50 meters ahead. Okay, 71 centimeter. No, sorry, 1 meter. Well, we are moving to locus to target the right side. Okay, and in the elevation we need to down 4 meter 40 centimeter. Okay, we need to move to the right side to stake out the point, and the reference of the elevation is 4 meter 40 centimeter. Okay. At the end, we need to make all the mark in the field. Bueno, I hope you like it, our presentation and the workflow that we follow in using the different applications that developed Appletop under the umbrella that offer us ZWCAD 2024 to work easy with our application combines to facilitate our work in day by day. No, bueno, I hope you like it.
Yes, thank you so much, Antonio. Thanks for your excellent demonstration of your application. I saw some audience raise their hand, so maybe we can offer the opportunity for the question.
I have here some new questions. There is James Ofton says if there is any option to view the model survey virtual reality. In fact, we have an option that allows you to export the digital terrain model to several formats, for instance, to OBJ, that you can, with this, you can open with special 3D applications like Mesh Lab and others. And even we have an option to export to Oculus Rift viewer. So that you can load a specific application and you can work using virtual reality if you have the Oculus Rift glasses. Elias Gerju asked if you can edit the terrain model dynamically. Of course, you can. The triangulation, and once you have created the triangulation, there are many tools to edit the triangulation. You can insert lines, change lines, add and delete points to the triangulation, and even you can see in real time the contour lines, how are dynamically changed, and so you can see easily the result. There are many, some other questions that has been done previously. Is the application can offer 2D and 3D data to illustrate cover levels and invert levels for sewer and surface water drainage? And yes, the software has a pipe network module that allows you not to calculate the network, but to draw in 2D and 3D, both in top view and in top view and profile view, the pipes, and even to create a 3D drawing and even export this to IFC for in projects. There is a new question about the precision. The precision depends on the accuracy of the data imported. Even if you have measured with a GNSS or a total station, you have captured data with these devices, you can import data, and MDT shows you the estimated accuracy of any point of the triangulation. Another question: if it's possible to grade around a building footprint that has relatively complicated geometry and variations in elevation. MDT has grading tools that allows you to create an esplanade, a pond that can be based on grade elevation or terrain elevation, and you can edit the elevation of every vertex of the polyline defining the explanation, and also even you can define for each segment of the esplanade, you can define the cut and fill slopes. So yes, it's possible. The license, you need the ZWCAD Pro license, professional. It's needed to have the professional license to load external application like MDT. And of course, if you have other applications, the MDT installation is very clean, so you can maintain other applications working in ZWCAD. Yeah, no problem. How you get a scan using laser scanning or photogrammetry? Well, in fact, our software TCP Point Cloud Editor allows you to work with point clouds coming from LiDAR sensors, a scanner, both fixed scanner and SLAM mobile scanners, and even with photogrammetry applications. That this application and point clouds generated from pictures taken from drones. All of them, all of these point clouds can be processed by Point Cloud Editor. Handheld scanning, what kind of cost? Well, there are many different equipment and many different brands, but the software allows you to work from an expensive solution, like for instance a an iPhone with iPhone Pro that has a LiDAR, a small LiDAR, with some applications allow you to create a point cloud, exporting in standard formats like LAS or E57, and import and process them with point cloud editor or even with ZWCAD directly. And also you can use professional equipment like SLAM scanners, SLAM scanner or fixed scanner. There are many different manufacturers, and all of them produce point clouds that can be imported by a point cloud editor. Regarding commercial terms and support for commercial terms, you can contact with Felipe Grande, that is our international business development manager, in case you want to become our dealer. And for technical support, you can contact us directly. I can write here the support email, that is support.@apritol.com. There are another question. You have a land that lower than a road needs to be filled. We need to make this number higher. Can we make a calculation of half mass volume? Of course, you can compare. There are many tools for calculation of volumes, cut and fill volumes, and you can compare both surfaces and create a map with cut and fill volumes and a full report in Excel. And you can generate a lot of different reports about this. In the video, there was a man walking with a handheld scanner. Well, in this case, it's a StoneX X120. And also, Antonio was using a GNSS, a Pronivo. I think it was a Pronivo receiver. I don't know if there are more questions. I think, can we use is the way I recorded? Maybe Michael or Enrique can answer this. Can we have access to the recorded video?
Yes, Jonathan, we're already recording this video, and we will publish this video on the official website of ZWCAD. So you still can check this video later, or you can contact ZWCAD directly to get your information what you need.
Okay, great.
Okay. So no more question now?
Can we export solids from point cloud? Well, point cloud editor is not for, you can create solids, but solids for terrain. That is, you can create a surface. Yes, exactly. You can create meshes, and you can export a mesh to standard formats like both vectorial formats like land XML, also raster formats like GeoTIFF, for instance, and even 3D formats like OBJ or IFC. And even you can, regarding IFC, you can not only export but also import. Even, for instance, a complete project you can import in Point Cloud Editor and consult the properties of the entities. Yes, you can. You need to convert to solid. You need to convert to a 3D 3D objects, not a surface that are really 2D or 2.5 dimensions. It seems there is no more questions.
Okay, so thank you so much for the efforts and from the ApplyTalk team, and thank you for the time for all the audience. Thank you for your participation. So if you still have any question, you can feel free to contact with us directly or contact with the ApplyTalk team in the future. So I guess that's all for today. Thank you so much. We'll see you next time.